Okay, this is going to be, now you got to pay attention to this, okay? Limits involving infinity. Limits involving infinity. There's two different ways you can see an infinity on a limit. You could see infinity as the thing that x is approaching, or you can see infinity as the answer to your limit. Okay? So we're going to look at both of those. And a good function to look at is f of x equals 1 over x. Okay? F of x equals 1 over x. Do you guys remember what that looks like, or what that's called? 12 basics. Which one is that? That is the reciprocal function, which looks like, I know, it's been a while. It looks like this, okay? Alright, it looks like this. Now, see, graphically, it's easier to see limits graphically. So, you know, if you want to graph the stuff or check on the calculator, that's okay, but I do want you to be able to work these out by hand too, alright? So let's look at the limit as x approaches infinity of 1 over x. So we can see graphically that as where x approaches infinity, where is that? Well, as x approaches infinity is like all the way this way. It's farther than you can imagine. Okay? So what's happening to the y value of this function as x approaches infinity? It's decreasing, and what is it approaching? It's approaching 0. Okay, so the limit of this equals 0. Let's look at the limit as x approaches negative infinity. What does negative infinity mean we're doing? Going all the way to the left. Right? We're going all the way to the left. So what are we approaching as we go to the left here on this function? We're still approaching 0, right? We're still approaching 0. Now, what do we have here at y equals 0? What do we have? What do we call that? Yeah, what kind of an asymptote? A horizontal asymptote, okay? We have a horizontal asymptote. So, you learned about that in Algebra 2. We did it some earlier this year too. And I think did we talk about it with limits? I think we did earlier this year talk about it with limits. But we're going to kind of refresh that again. But whenever you see this, the limit as x approaches plus or minus infinity, we are talking about horizontal asymptotes. It's the same thing, okay? The limit as x approaches infinity is the y value that you get as x goes all the way in one direction or the other, but that's actually the same thing as a horizontal asymptote, okay? It's the same thing as a horizontal asymptote. Now, let's look at where infinity is going to be the answer to this, which in this case, we're going to look at the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right of 1 over x. Okay, so let's look at this graph here and see if we can tell what it is. So the limit as x approaches 0 from the left is this side, and we're approaching 0. So what's the y value doing? It's decreasing. And it keeps decreasing, right, forever, because we can never hit this 0. So we have the answer to that would be negative infinity, right? And then as we the limit as x approaches 0 from the right, we're looking at this piece and approaching 0 from the right, and that, of course, is going to end up being, yeah, positive infinity, okay? So you guys, notice how, and what do we have there on the graph? A vertical asymptote, okay? So when the infinity is down here with the x, we're talking about horizontal asymptotes. When infinity is the answer to your limit, that's always going to be a vertical asymptote. Okay? So now you're actually learning where these asymptotes kind of come from. Okay? So you guys see the difference there? We got infinity with the x over here. That's going to be a horizontal asymptote. We got infinity as the answer over here. That's going to be a vertical asymptote. Always. Okay? And when you do the vertical asymptote, this right here, when x is approaching, that won't always be 0, but it will always be a number. Okay, that will always be an x value that you're approaching, and you're going to have it from the left or the right always, because there's a vertical asymptote there. You're never going to be able to cross over that anyway. So you're going to have to be approaching, when it's a vertical asymptote, you're going to have to be approaching a number from the left or the right, and your answer is going to be positive or negative infinity for vertical. Okay? Any questions on that? No, not really, not quite. So let's go back to, think back to Algebra 2 for a second here. And we have some, if you were given a rational function and you had to say what the horizontal asymptote was, remember how you figure that out? There's like 3 rules. Close. Yeah, close. It's the exponent you want to look at. Okay. Yeah. Yeah, so remember your horizontal asymptote rules is you're looking at the exponents. Look at highest exponent on top and bottom. Yeah. So if it's if bigger on top, you remember what that was? No, there's no horizontal asymptote if it's bigger on top. Okay. If it's bigger on the bottom, we're talking about the exponents now, right? It's bigger on the bottom, then the HA equals 0. If same exponent, then you take the coefficients. Okay. So if I had f of x is equal to 3x squared minus 10 over 4x squared plus x plus 8, if I want to find the horizontal asymptotes of that, I look at the exponents. They're the same. So the horizontal asymptote is 3/4. Okay. Now, the limit as x approaches infinity, let's look at it this way. We're going to get the same answer because that's what this means, horizontal asymptote. Okay. The limit as x approaches infinity. Of 3x squared minus 10 over 4x squared plus x plus 8. Now, if we have infinity squared and multiplied by 3, if we subtract 10 from that, it's really not going to make a difference. Okay? That's why you can just get rid of this. If we have infinity squared multiplied by 4, that's getting so bigger, so much faster than just this x by itself, or adding this 8's not going to make a difference either. So infinity squared gets bigger much faster than infinity. Infinity cubed gets much bigger much faster than infinity squared or infinity. Okay. So the higher the exponent is on these, the highest exponent matters. The rest don't matter because they're going to be insignificant compared to the highest exponent. So these don't matter. Okay. So you cancel everything but the highest exponent. Now we have x squared on both of those, so those can cancel, and we're left with 3/4. And okay. Yes. The limit as x approaches infinity. Make sure that as long as you have this, we're talking about horizontal asymptotes. And you can do it either way. You can think of it as plugging in infinity and canceling everything that doesn't matter, or you can just use your exponent rules. But realize that the exponent rules just come from the fact that the lower exponents don't matter when you plug in infinity. Okay, so that's why you're able to do that to get your horizontal asymptotes. Okay, if we have the limit as x approaches infinity of, say, let's change this to 3x cubed plus 10 over 2x squared minus 8. So now that's bigger on top. Now there's no horizontal asymptote, but there is a limit. Okay? What's going to happen here as x goes to infinity, what's going to get bigger, the top or the bottom? The top. If the top of a fraction gets bigger, the whole fraction is getting bigger, right? So that the limit to that would actually be infinity. Instead of, it doesn't have a horizontal asymptote. That's still true, but it does have a limit, and it'd be infinity. Okay. If we look at the last kind here, where we are, let's say, x plus 8 and 3x cubed minus 2. Okay, so on this one, if you think about plugging infinity in here, you can go to your exponent rules and say it's bigger on the bottom, so the answer is 0. That's fine. But also understand that the top is getting bigger much slower than the bottom. I should say the bottom of this fraction is getting bigger much faster than the top of this fraction. If the bottom of a fraction gets bigger faster, the whole thing is getting smaller, right? The whole thing is getting smaller, and that's why, if you have an exponent bigger on the bottom, that's why your horizontal asymptote is always going to be 0. Because the bottom of that fraction gets bigger much faster than the top of that fraction. Okay?